Our next presentation is entitled Sensitivity of Athelia rolfsii from a Commercial or Research Peanut Fields in Georgia to Tebuconazole and Flutolanil. And our presenter is Jessica Bell.
Thank you, Dr. Kimwright, for your introduction. Like you said, my name is Jessica. I study under Dr. Tim Brenneman at the University of Georgia. And again, the title of my talk is Sensitivity of Athelia rolfsii from Commercial or Research Peanut Fields in Georgia to Tebuconazole and Flutolanil. So just a brief background on peanut, or Rachis hypogea. It is, of course, native to South America, and it belongs to the family of legumes, or Leguminosae. And it is a very worldwide important crop due to its oil, food, and feed properties. Unfortunately, this crop can be devastated by peanut stem rot, or Athelia rolfsii. And just to hit a few of the highlights, this is a worldwide soil-borne pathogen, and it does favor very warm and humid climates, which is unfortunate for us in the Southeast. It does infect both above and below ground tissues, which can make it very difficult to control. And in very severe cases, it can even cause up to an 80% yield loss in peanut. So this can be very devastating for the peanut growers. If you look at stem rot control specifically in Georgia, for more than 20 years now, we have very heavily relied on fungicides. We use 3 different groups to control this pathogen. We have the SDHIs, which is the group 7, the DMIs, or group 3, and the QOIs, which is the group 11. And I also have a few active ingredients listed for each as well. These are typically pretty effective at controlling this pathogen. However, just because you have a good fungicide program does not necessarily mean that you will see great control in your field. So why might fungicides not control stem rot? And there are several reasons for this. First of all, you're going to have some deposition on that foliage in your upper canopy. When you apply these applications, of course, you want it to go through that canopy to the target site, which is at your soil line, because of course it is a soil-borne pathogen. Some things you can do to just help mitigate this would be apply your sprays at night when the leaflets are closed, or even just washing off with irrigation afterwards. Just anything to maximize that fungicide soil contact. Secondly, there could just be misapplication errors or spray timing issues. Thirdly, we are currently actually investigating enhanced biodegradation. We think that it might be occurring in some of these peanut fields, which would help explain some of the lack of control. And what this means is after repeated applications of the same active ingredient to the same location, the microbial populations get very accustomed to breaking it down rapidly. So next time you spray, you're not going to have much left in the soil to control your stem rot. And lastly, a lack of control in your field could very well be due to reduced sensitivity. And this is what we're going to focus on for the remainder of my talk. And with that, if you look specifically at rotational crops for peanut, especially like corn and cotton, used to these crops did not receive fungicide applications at all. And now not only do they receive fungicides, but they're getting pretty much the same groups that we spray on peanut for stem rot. And again, those are classes 3, 7, and 11. So this really sets the stage for us possibly having reduced sensitivity. So as a result, my hypothesis for this study was that with the frequent application of similar fungicides to peanuts and their rotational crops, we think that we may have some reduced sensitivity in some of our peanut fields, which of course could help explain reduced control. As a result, my objective was to analyze the fungicide sensitivity of Athelia rolfsii from peanut fields across the state of Georgia, where disease control with these fungicides was a little bit less than we expected it to be. So moving on to my materials and methods, I collected my samples from 14 different commercial or research fields across the state of Georgia, wherever there was significant losses due to stem rot. And you can see on the image on the right, there are 8 different counties represented. I then tested the in vitro sensitivity of about 20 isolates per field to Tebuconazole and Flutolanil. I then compared the sensitivities to a test that was done in the 1990s by Dr. Michael Frankie. This was a very extensive study, and I think we got some very interesting results being able to compare my data to his data, which I'll go over in just a moment. So when I collected my samples, I took single sclerotial isolates from arbitrarily selected diseased plants throughout these different fields. I then grew them out in the lab on PDA, and you can see on the image on the bottom left, I took a hyphal plug from the very edge of the actively growing mycelium. And on the image on the right, you can see I transferred it to a petri dish that contained a quarter PDA with a amended fungicide medium. And I used one discriminatory dose when I amended this fungicide medium. So it was the same that was used in the 1998 study. And for Flutolanil, that was a 0.03 part per million. For Tebuconazole, it was a 0.02. And I applied both of these in 1 milliliter of acetone. So for my control, it also got 1 ml of acetone per liter. I did 2 replicates of each treatment isolate combination. And I incubated them in the dark at 26 degrees Celsius for 3 days. At the end of that incubation period, I removed the plates and measured the diameter of the mycelium growth. As you can see by the red arrow, I measured from the edge of that plug all the way to the portion of the widest growth. I used that data to calculate percent inhibition using the following formula, and I analyzed my data in SAS 9.4 using a generalized linear model. So moving on now to my results. You can see here for Tebuconazole, on the left-hand side, I have the locations, and each one that I've starred represents a grower field. I then have the number of isolates per location that I screened. And for percent inhibition, I have the range and the mean per location as well. You can see on the right-hand side at the bottom that my mean range is about 15 to 21 with an average of 18. It is important to point out, I think, that we did have some hormesis in a few of these isolates. You can see a negative percent inhibition on a few of these. And in a similar manner, I have Flutolanil data listed here in the same format. The mean range of percent inhibition is about 15 to 25 with an average of 20. And I will also mention that there was no consistent differences between the grower fields and our research sites. So I have here the same data listed in a different format. On the y-axis, I have percent inhibition, the mean percent inhibition. And on the x-axis, I have it by the locations. Again, the average mean is listed below each table. So for Tebuconazole, you can see that I have 2 significantly different groupings across the 14 fields. And in Flutolanil, we saw a little bit more variability because I have 6 different groupings across the different locations. So I then wanted to compare my average mean percent inhibition to the data that was collected 22 years ago, which I have represented here in the same exact format as before. And you can see with Tebuconazole on the left bottom, the average mean percent inhibition was about 28, and for Flutolanil, it was about 30. So I then compared this data set to mine. And on the y-axis, again, I have the average mean percent inhibition. And on the x-axis, we have the year the data was collected. The green represents Flutolanil and the blue Tebuconazole. So you can see for Flutolanil, 22 years ago, we started at 30.08, and over the next 22 years, it was reduced down to about 20. This represents a 32% reduction in percent inhibition over time. And in a similar manner, Tebuconazole went from 28 down to about 18, which is a 36% reduction. So there were definitely significant losses over time in this percent inhibition. Something else we wanted to note about the 1998 study is that they found a very surprising positive correlation in the sensitivity between both Teb and Flutolanil, which indicates possible cross-resistance across those 2 different modes of actions. Again, one's an SDHI and one's a DMI. Our results, however, did not show any significant correlation whatsoever between Teb and Flutolanil, which is more what we would have expected in the first place. So moving on to a brief discussion. Again, just to reiterate, my objective was to analyze the fungicide sensitivity of Athelia rolfsii across Georgia. And once we did so, we did see significant differences across the locations and in regards to each fungicide. However, we don't think that those differences were dramatic enough for us to think that there would be a large difference in disease control in the actual fields. Secondly, the current populations are definitely less sensitive than they used to be 22 years ago, but we don't really know at this point what that means in terms of disease control, but that's something that we're trying to look into a little bit further. And then again, we did not see cross resistance between Teb and Flutolanil. And something to kind of consider with the last 2 points that we've made here is what about the new active ingredients within some of these chemical classes? A lot of our newest products for stem rot control are DMIs and SDHIs. So the question I think needs to be asked, if we saw a reduction in SDHI and DMI sensitivity over time, it may be affecting some of our newer chemistries. It might be that they're not quite as effective due to what we've seen with my results here. As far as future direction, we would like to determine the mechanisms of DMI and SDHI resistance in Athelia rolfsii. And again, like I mentioned at the beginning of the talk, we are currently looking into whether or not enhanced biodegradation could be responsible for some of the lack of disease control in our field. And with that, I thank you for your time, and I'll take any questions.
Thank you, Jessica. And we do have time for questions. The first question comes from Leslie Comey, and she says, please, did you check the influence of acetone on fungal growth before using it as a control?
No, we didn't. I used such a small amount, though. I really highly doubt that it had any effect on the pathogen, but I mean, that's something that I could do in the future. But across all these studies that I kind of patterned my methods after, they've done the same thing.
Any other questions for Jessica? I have one question. That is, how is there been within the ag chem industry, that's probably nobody is more effective than the growers might be, but then second to that would be those who are producing products. Has there been much interest in your results so far, or are they even aware of your results so far in terms of our friends in the chemical industry?
No, sir. The results are pretty recent, but hopefully we'll make them aware of it very soon.
I can assure you they'll probably call you. So thank you very much for this presentation.
All for your time.